50 years of exploration.
50 years of discovery.
50 years of innovation.
50 years of breaking boundaries.
I'm Molly McKinney.
And I'm Caleb Kinchlow.
Join us as NASA 360 presents I Love the Solar System.
A look back at 50 years of solar system exploration. We're all used to seeing incredible images from our cosmic backyard. Neighboring planets, their moons, comets, and asteroids.
But it wasn't that long ago that places like these were nothing more than points of light through a telescope.
So how do we get from here to here? Well, it wasn't easy.
It took hundreds of thousands of people of diverse backgrounds and expertise working across disciplines and extending through decades.
Perhaps people don't always realize is just the enormous number of people involved in these missions and all the different kinds of skills they have.
You know, in order to make these planetary science missions work, it takes thousands of people.
Well, NASA is a very diverse place.
I'm a geologist. I work with people who are, atmospheric scientists.
You need someone who's skilled in molecular spectroscopy.
Geochemists.
There's mineralogists.
Folks who are skilled in measuring magnetic fields.
There's a lot of different ways to contribute to these missions.
We need the engineers to build the spacecraft.
Mechanical engineers, electrical engineers.
We need people that know the optics.
Software people.
All kinds of people who study science, technology, engineering, math.
If you're passionate about space,
there's no one particular type of person that works on any planetary mission.
And as long as you have some other talent,
you get a really interesting diversity of backgrounds and expertise.
Then we need you.
This is an exciting way to use those skills to explore something that no one's ever explored.
Let's just start 50 years ago. Everything we knew about the solar system came from the back end of a telescope.
Nothing more than fuzzy pictures from even the largest telescopes.
We were putting together a picture of what are our planets, what's the inventory of our solar system, and we found the asteroid belt and the 9 planets at that time.
We've come an enormous way in 50 years. It's unbelievable the kinds of things we've discovered.
We've come from an era of pure science fiction to an era of unbelievable science fact, science reality. We have bridged that abyss.
In every young person on the planet we have wanted to know and do what we were doing.
Those first flybys and encounters with planets were basically done with good engineering with our scientific eyes wired shut.
And you were assured that whatever instrument you built, you're going to find something new.
To go from the very early steps of just being able to get something off the launch pad in Florida, away from the Earth, on the right trajectory to get to Venus or Mercury or Mars.
I think all of a sudden, we were really opening a new window on our universe.
The new age of being there, planetary exploration, opened with Mariner 2, a mission to the planet Venus.
Now prior to that, we had 4 lunar missions that failed, and Mariner 1 didn't make it either.
The reason Mariner 2 got to Venus is because Mariner 1 had to be blown up by the range safety officer a few seconds after launch out of the Cape.
So Mariner 2 flew by Venus and discovered a number of things that are incredibly important. For instance, it found out that Venus didn't have a magnetic field.
Venus is a really inhospitable place.
The clouds are made of sulfuric acid. It's got runaway greenhouse gone wild.
The highest temperatures of any planet in the solar system, actually even runs higher than the hot places on Mercury.
You can melt lead on the surface.
It actually spins backwards, rotates backwards.
That temperature is evenly distributed around the whole planet, not only on the day side, but on the night side of Venus too.
You have to start somewhere, and so that was an incredible accomplishment just to be able to get away from the Earth and have everything work properly.
Mariner 2 opened our eyes to the diversity of possibilities in the solar system, because before Mariner 2, people thought Venus might be a place that was almost hospitable.
Up until that point, there was a lot of science fiction that there could be beneath the clouds a very tropical, Earth-like environment.
Those first instruments from that first flyby showed us a real planet that was different, hotter, more challenging, and no less interesting.
Venus is so similar to Earth. Venus is similar in size, similar in mass, similar in location in the solar system. It should be very much like Earth, and yet Venus is nothing like Earth.
Really, what is the real Venus? We don't know. And so, in today's era of planetary exploration, Venus remains one of the big enigmas, and one of the places where a lot of planetary scientists think we have to get back.
It turns out what we discover ends up leading us to new questions.
The Mariner 4 mission was the first to take us to Mars, and in doing so, changed everything we thought we knew about the Red Planet.
There is this mystery of Mars. Mars is unavoidably special.
The red planet, it's so often visible in the sky that, you feel like it's just over there.
Mars has been subject of a lot of speculation for a long number of years.
Many astronomers in the late 1800s were seeing what they saw were little features. They eventually called them canal or canali. Those were really believed to be, by some astronomers, areas of vegetation.
Well, Mariner 4 was the first U.S. probe that actually got to Mars.
We found what looked like a pretty barren moon-like world.
Oh my God, there were these big craters.
It made it look more like the moon than it did like the Earth.
There was a real change in the perception of, how hospitable that the solar system off of this planet might really be or not be.
But it wasn't until Mariner 9 went into orbit around Mars that we really began to see some thrilling results.
We arrived during a global dust storm.
But when the dust cleared, then you could see that the entire surface was covered by former seas and mountains.
Yes, there are craters, but there are also spectacular regions on Mars.
Now we had Olympus Mons, which was 3 times the height of Mount Everest.
Ancient volcanoes on Mars? Whoa. That means Mars was a living planet at one time.
You had the Valles Marineris canyon system.
It's deeper than the Grand Canyon. It would stretch across the United States and is one of the most spectacular features in the solar system.
Mariner 9 and Mars, it gave us the hope. It gave us the hope to do Viking.
Well, Viking was a spectacular leap forward.
It was so tremendously ambitious that we thought we could, put something on the surface of another planet and, just play around in the dirt.
I sat in a room with a lot of other engineers and scientists as the first images from the first Viking lander started to come down.
To actually see those first images coming back scan line by scan line by scan line.
A line by line by line. It was, a slow buildup.
It's like any explorer going on the other side of the hill for the very first time. It's that same kind of feeling that you are seeing something that no other human has ever seen before.
I think one of the most amazing achievements of the last 50 years is actually landing the rovers on Mars.
It's the mobility. It's being able to say, hey, I want to go look at this rock over here and drive over there.
Nuzzle up next to a rock and measure it, identify the composition of things around the landing site.
The first rover on Mars, we all know, was the Pathfinder Sojourner rover, which was something about the size of a shoebox. Cute little thing,
I was one of those kids logging onto the internet, refreshing the page, trying to get the next images back from Pathfinder.
It was only supposed to last a few days, and yet it lasted over a month. And to really feel like, wow, we've actually set wheel on another world was just amazing.
Well, Mars is such an fascinating planet, and the more we learn about the surface, the more indications we get that it was this warm, wet, maybe even Earth-like planet.
We continued to follow the water through the confidence we got with Pathfinder to the rovers, Spirit and Opportunity, the 90-day missions that were gifts that keep giving.
The MER rovers have helped us understand the history of water on Mars to a great detail. They're geologists.
They were really looking for evidence that water ever flowed on the surface of Mars, and I think we've now established that that was the case.
We know now that water still exists under the surface, just a few meters under the surface, and also on the polar caps.
Water is one of those essential ingredients for life.
And that gave us the confidence then as we pre-planned Mars to say, okay, what's next? Let's send the labs, the kind of labs that would tell us about the building blocks of life.
The analytical instruments on the Curiosity rover are the most complex, specialized set of instruments ever sent to another planet.
Just the sheer feat of landing Curiosity with the sky crane and everything else that needed to work, that just blows my mind.
As if we weren't spoiled enough knowing that we landed successfully. We got a picture there to prove it.
Those first pictures came out, and I still didn't believe we had landed.
I do this constantly thinking, did it really happen?
It just still gives me chills.
And it's sitting right now on what we believe is an ancient riverbed.
Oh my God, seeing that mound, that 3-mile-high mountain in the middle of this crater with these, valleys and networks, it's just unreal.
It's like science fiction became real. We now have a smart rover on Mars that can do things that 30 years ago we couldn't do in Earth labs.
There are people working on the Curiosity mission who literally weren't born when Viking landed on Mars.
I think people forget that, you know, back in the day, this has never been like falling off a log. We've just made it look a lot easier.
Don't space out.
NASA 360 will be right back.
If you want to look back in time to the beginning of our solar system, look no further than comets and asteroids.
These solar system time capsules have been giving away secrets of not only how our solar system formed, but also the planets that call it home.
What are the materials that formed the solar system? What did it look like originally?
Asteroids and comets are the leftover material that made up the solar system.
Some of which were made 4+ billion years ago.
So it turns out that these things really have a lot to do with how that the solar system has evolved.
With respect to understanding the chemistry that happened before life emerged on the Earth. How did we get the building blocks to the early Earth? And one of the theories is that fragments of comets and asteroids could have basically delivered and seeded the early Earth with these compounds.
We have a chance by studying asteroids and comets to put our hands on relics from the time the solar system formed.
NEAR, the Near-Earth Asteroid Rendezvous mission, it was our first close-up examination ever of an asteroid.
One of the big questions had always been, where is asteroid a rock pile of material, or is it actually a solid body?
We were able to take that mission and softly land it on that surface of a huge asteroid called Eros.
Well, we learned a little bit more about the geology of asteroids, and we also learned a little bit about the composition.
When we went to Vesta, most recently with the Dawn mission, we realized it is an initial building block, what we call a planetesimal. It takes many of those to get together and accrete to create the next phase, which would be a planet.
We've tracked Vesta, next stop, Ceres.
Dawn is on its way to go to Ceres, the largest of asteroids, and I only expect more amazing things, but also more head-scratching things to come from that mission.
Now, comets are interesting because they are even more primitive than the asteroids.
We sent the Stardust mission out to rendezvous with a comet.
And this was NASA's first cometary sample return mission. It brought back pieces of dust and volatiles, gases, from the tail of Comet Wilt 2.
We're analyzing it constantly. We take it to a variety of laboratories, we dissect it, we look at every bit of it.
And indeed, we found glycine, which is the simplest and most abundant amino acid in life on Earth, in these cometary materials. So it provided the first evidence that comets could have seeded the early Earth with some of the ingredients of life.
Deep Impact was a fabulous mission. The concept of being able to fly by a comet, but drop off an impactor.
It impacted the comet so it would blow out some of the material of the comet so we could then examine it with the flyby. A scientist will be studying that and learning about the nature of the comet for years from the data that was returned.
You know, I had my predisposition about comets and that they were kind of uninteresting kind of chunks of stuff hurtling around the solar system. And then you get these incredible pictures back and show that comets are these incredibly diverse, geologically significant bodies that have craters and faults and folds.
One of the exciting missions that's due to launch here in a few years is called OSIRIS-REx, which is NASA's first asteroid sample return mission. We're gonna, fly to this asteroid, we're gonna orbit it for about a year, map it, figure out a good place to touch down, and then just kind of gently coast down to the surface and do this quick touch and go and collect a surface regolith from this asteroid.
We'll bring it back to the labs to study. I mean, that will be like bringing back the moon rocks, but we'll do it for a primitive object. Awesome.
It's this continuation of trying to figure out how you put all the pieces of the puzzle together.
Out beyond the asteroid belt lie the behemoths of our solar system, the gas giants.
And NASA has sent a series of spacecraft over the years that have revealed some surprising secrets of the outer solar system.
The next wave of discovery, and beyond Mars, was the outer planets.
Pioneer 10, Pioneer 11 were, the first two spacecraft to actually cross the asteroid belt.
Our first foray into the outer planets.
We were able to go and see these gas giant worlds for the first time by actually being there. What the mission did was not solve all the questions. What it did was it raised the right ones to ask next.
Voyager just blazed a trail of new knowledge throughout the entire solar system.
The grand tour of the solar system, right? These planets only align, I think, every 176 years. So there was that one shot in 1977 to do it.
When Voyager observed Io, the moon of Jupiter.
Was it a rotten orange or a pizza pie?
And one of the graduate students noticed this protrusion at the edge of Io and said, "Look at that." He said, "Volcanoes."
Not seen anything like this. Oh gee, except on Earth when volcanoes erupt.
Io is the most volcanically active body in the entire solar system.
One of those, oh my God moments. We have something new.
Rather unexpected indeed.
It was this long odyssey from one world to another over decades.
We had close-ups of all of Jupiter's large satellites.
Voyager did that. It, of course, went to Saturn and saw the myriad of moons.
And then, of course, Voyager 2 went on to Uranus and Neptune, and 99.9% of everything the human race knows about Uranus and Neptune was learned as a result of those two Voyager 2 flybys.
And then it's just kept going and going and going.
Remember, these spacecraft are still working right now. They were launched in August and September of 1977.
And going and going.
It's still sending back data from the very edge of what we would call the solar system.
And going and going.
To imagine that this little tiny spacecraft is just trudging along and then reaching the outer limits of our solar system.
Those missions begat the next phase of exploration of the outer solar system with, of course, Galileo at Jupiter.
We now knew we needed to get back to Jupiter and get into orbit.
Galileo had a problem with unfurling its giant 12-foot antenna.
All of a sudden, instead of 100,000 bits per second, we could only transmit 10 or 20 bits per second.
We figured out a workaround to still capture the critical data, even at a data rate that today would frustrate the kids of the world.
And nevertheless, we learned a lot of things by virtue of the fact that we were in orbit around the planet. We stayed there for a long time. So that was a terrific mission.
One of the missions that sticks out is actually a recent mission, the Cassini-Huygens mission.
Cassini's like the World Series of planetary exploration.
Cassini gave us our first sort of close-up real images of the planet Saturn.
You must think of Saturn and its satellites as a planetary system.
You get this unprecedented look at Saturn's moon Titan.
And then it drops off this probe called Huygens that actually lands on Titan and sends back images from the surface with these little icy cobbles.
I mean, Titan is another world with meteorology on it.
And it's raining methane in the southern hemisphere right now.
And we see lakes of liquid hydrocarbon on the surface of Titan.
Nature seems to be far more imaginative than we are.
The real sleeper on the Cassini mission is Enceladus.
During the flyby, we found this plume of ices emanating from the South Pole.
These incredible geysers that are erupting ices and water and ammonia.
But more importantly, the mass spectrometer on the mission found simple organic compounds, hydrocarbons.
One of the things that you need for life is water, and you need organics. And it's interesting because these plumes that are coming from the South Pole of Enceladus seem to have a little bit of both.
Many people ask NASA, well, what do you think? Is Pluto a planet or not?
Whether it's a planet or not, and whether we grew up with Pluto being a planet.
Our opinion is we don't care. It's an object worthy of study.
This is really kind of the last outpost in our solar system.
And New Horizons is going to fly by Pluto and all the other moons in July 2015.
Being able to finally resolve the surface of Pluto and its number of moons, its growing number of moons, that's certainly going to be really cool.
And that's really incredibly fascinating that even today we're finding new things about our solar system.
It really is sort of the final voyage of discovery of looking at this first piece of what is really out there in the depths of the dark.
With 50 years of solar system exploration under our belts, each new discovery raises more questions than answers.
So, what's next? NASA will continue to raise the bar as it further expands our understanding of the solar system around us, as well as our place within it.
We have flown by, we've orbited, we've landed, we've roved, and we have returned samples.
We've come so far in our understanding, and yet we have so far to go. There's so many questions we don't have answers to yet.
Can you imagine if we never explored where we would be as a species?
I think we explore because it's in our bones. I think it's something that humans were born to do.
I think we explore because we're alive. I think it is the nature of life to explore.
Humans are just naturally curious. We always want to know more, and I think that every time we do a mission, instead of answering all of our questions, it actually opens up more questions to us.
And in fact, there's a major realization going on now that the solar system is still evolving. It's still changing in major ways.
And it turns out that we continue to learn things about our own planet by looking at the other planets.
We look at Venus, one of our nearest neighbors, and that has profound implications for climate change, for the greenhouse effect.
Understanding about chlorofluorocarbons and their role in ozone destruction actually came out of the planetary program trying to understand what exactly was going on with the upper atmosphere of Venus.
The things we learn about Titan and its atmosphere are having strong influences on how we understand Earth's atmosphere evolved.
The Earth is an incredibly special place. And the more we study these other planets, the more I think we appreciate how really special the Earth is.
For me, I think exploration boils down to one thing, our curiosity, the ultimate question. Are we really alone here? I know I don't want to be.
How do we detect the fingerprints of biology off planet Earth on really tough places?
Whether we're looking for life in the sedimentary layers on Mars or in the oceans of Europa or trying to find the pale blue dots around other stars.
Is there life beyond Earth? And to understand that, we have to understand how the origin and evolution of the solar system has got us to where we are today.
Everywhere we turn, the solar system is trying to tell us, if you think you got it all figured out, you better think again.
All of this eventually informs us about where this little blue dot that we live on came from. And that's what all of this is all about.
It took over 60 years to go from the Wright brothers' first powered flight to landing humans on the moon.
And in just 50 years, we've gone from the first successful planetary mission to the Voyager spacecraft reaching the very outer edges of our solar system.
Now imagine what's possible in the next 50 years.
That's right. Well, that's it for today. I'm Molly McKinney.
And I'm Caleb Kinslow.
Thanks for watching NASA 360 Presents I Love the Solar System.
I love the solar system because there's so much of it that we haven't explored yet. There's so much left to do.
I love the solar system because the more we learn about it, the more questions we have, and the more work we have to do.
I love the solar system because it is a challenge.
Because it's home. Because it never, ever ceases to wonder.
I've always thought that knowledge is better than the alternative.
I love the solar system because it's there to explore, because every time we think we've found something out, we've just opened up a whole new box of new discoveries to make.
What I love about solar system exploration is that they're not just individual worlds. They all fit together. They all tell a story that is truly mind-boggling.
I love the solar system because there are so many elements out there that are similar to things that we know and understand on Earth, and yet none of them are the same.
Because we, like detectives, we are cosmic detectives, and we can go in and read these clues.
I love the solar system because it's where we live. It guides, it shapes our planet. It's where we were born.
Well, I love the solar system because it's ours. Let's take it.